Hi everyone, welcome back. My name is Loyani, and in the previous video we worked with components templates and learned how to bind data and handle user interaction. So far, we've been using regular class properties to manage component state. In this video, we're going to introduce signals, the foundation of state management in modern Angular. So by the end of this video, you'll understand what signals are and why Angular introduced them, the different types of signals, what a writable signal is, how to use signals for local component state, how signals integrate naturally with templates, and we'll focus only on local state in this video, keeping things practical and approachable. So what are signals? Signals are the foundation of state management in Angular. They make state explicit and predictable. They are designed for local, synchronous UI state, and simplifying the concept, it is a value that can tell Angular when it changes. Let's take a look at this screenshot. This is an Angular application. We're going to be developing something similar to this throughout this course, but I would like to break this down into different components. So on the top, we have a header with the title Angular Shop. If you go to the right of the header, you have a products menu. You also have a shopping cart with 4 items on the cart. If we take a look at the center of the screen, we have a list of products. In this case, we have 3 products, and each of the products will have the name of the product, a description, the price, the quantity that the user decided to add to the cart, and also a calculated value, which is basically the price times the quantity. And we also have an order summary. So in this screen, we can see at least 4 to 5 components depending on how you decide to organize. Now, imagine that you are changing the quantity of products. We have to update the quantity in the order summary. We have the number of items in parentheses. There is also the tooltip within the cart of how many items we have in the shopping cart icon. If you delete a product, same thing. We'll have to decrease the quantity from the order summary and also from the tooltip from the product shopping cart. And likewise, whenever you are modifying the quantity, we also have to calculate the subtotal of each of the products and also calculate the subtotal in the order summary in at least 3 different places whenever we are interacting with the quantity of each product that we have to update within our application. So with signals, you'll see that this becomes much easier to be handled than pre-signals, what I like to call within the classic or the legacy Angular era. So before we take a look at syntax, let's talk why signals exist. What problem exactly is signals solving? Historically, Angular kept the UI in sync using change detection, and for a long time this was closely tied to Zone.js. Zone.js works by patching asynchronous browser APIs, things like promises, timers, DOM events, HTTP requests, and whenever something asynchronous happened, Angular would have to run the change detection and update the UI. This approach worked well, but it also meant that Angular often had to guess when the state might have changed. Change detection could run more often than necessary, and it wasn't always obvious what actually triggered an update. As developers, we adapted to this model. For simple components, we use plain class properties and rely on Angular to detect changes. As applications grew, many of us started using RxJS more heavily. For example, using observable, subject, behavior subject. RxJS is extremely powerful and it's still a core part of Angular today, but it was often used for local UI state, even when that state was synchronous. This led to patterns like subscribing in components, managing subscriptions manually. That was a big headache. It's still a big headache if we are relying heavily on RxJS and not adopting signals. We were using the async pipe everywhere in our templates. We were turning simple counters or toggles into streams. It worked, but it also added complexity and boilerplate. Signals were introduced to solve this gap. With signals, the state changes are explicit. The dependencies are tracked automatically, and Angular knows exactly what depends on what. So instead of relying on Zone.js to notice that something might have changed, Angular reacts directly to the declared state changes. This is also why Zone.js is being phased out and removed from the default Angular model. Signals allow Angular to be more predictable, be more performant, work without patching the entire browser runtime, and it doesn't replace RxJS, not as of right now. RxJS is still the right tool for HTTP requests for now, because we already have HTTP resources, which we're going to learn later, but it only supports GET for now. We still have to support post, put, delete, and patch. RxJS is still the right tool for streams of events, WebSockets, and complex synchronous workflows. Signals are the perfect use case when dealing with local synchronous UI state, and that's exactly where we're going to start. So just to give you an example, the project that is being shown on the screen, it's a package.json file. We have Zone.js. This was created with Angular version 20. If we take a look at the project that we have created within this course, we don't have Zone.js anymore. This means that Angular has completely removed Zone.js. If you are upgrading from modern and legacy versions to version 21 and above, you might want to remove Zone.js from your dependencies so you can really take advantage of signals. But of course, that might require you to do some refactoring within your application as well. Before writing any code, let's briefly talk about the different types of signals. Angular provides writable signals, which is just a value or state that you can change directly. Computed signals, which is a state that is based on other signals. Think about it as a computed value. And effects, which is just logic that reacts to signal changes. In this video, we're going to focus on writable signals. Computed signals and effects will come later once the basics feel more natural. Let's start with a simple example. Open the hello.ts, which is the hello world components we have been using so far. Let's create a counter. Usually it's being used by Redux whenever we are learning about state management as well in React, and it's a pretty straightforward example. So for the counter, I'm gonna start by declaring a property, which is a count. We also learned that for best practice, because this is only going to be referenced in the template, we're going to protect this property as well. We're not going to leave it public. And we're going to create this as a signal. To do this, all we have to do is just signal and then open and close parentheses. This signal also needs to be imported from the @angular/core package. So don't forget to also import Visual Studio Code. In this case, it's already importing this for me automatically. You'll see that we're getting an error because it also expects an initial value. For the counter, I'm going to pass 0 as my initial value. To read this value, we're going to open our template, so hello HTML, and I am going to declare another h1 tag here. I'm also going to use interpolation, which we have learned already. And to read the value of the signal, we'll make a reference to the name of our property, and we're going to add parentheses. So we call it as it was a function or a method. This is actually calling the getter function from this signal. This is a key part of the signal's mental model. A little bit different for the title, for example, we didn't have to pass anything. We simply declared a property. For the signal, we add the name of the property and add parentheses. Let's check this on the browser. So I'm just going to run npm run start to start my application. And going back, we have the 0 for the count. Now, we would like to increase this counter. So we're going to add a button. I'm just going to add the plus. And I'm also going to add a button for minus, like this. And when we click on this button, I would like to increase the counter. And when I click on the minus icon, I would like to decrease the counter. We have a compilation error because we don't have this method in our template yet. So I'm just going to come back here and add both methods so I don't have a compilation error anymore. And we're going to add the logic. Compilation error is gone and we can focus on adding the logic. So to increase the counter, what I would like to do is something like this. Count receives count plus 1. So how do we do this with signals? We can use two methods. I'm going to make a reference to the count signals. I'll have to use the this keyword. Remember, this is making a reference to this component. And then count. In this case, I don't need to pass the parentheses. And when we press the dot right here, we can see that we have a few methods available as well. There are two methods, the set and the update. The update, we can pass a function. It receives the value itself, which is the existing value, and we can use, for example, an arrow function to do something with the value. So in this case, I'm going to add the value, arrow function, and I'm going to do the value plus 1. It will be the same thing as doing count equals count plus 1. To decrease the counter, it's the same thing. Count, update, we're going to pass a value, and in this value, value minus 1. Let's see this in action. Going back to the browser, I'm going to click on plus. It's increasing the counter. When I click on minus, then it's decreasing the counter as well. So this is how we use the update function. We are updating the value of the signal based on its current value. What if we would like to reset, for example? So let's add another button, which is a reset button. And on click, we're just going to call the reset counter function. We're going to go back to the component. We're going to add this method right here. And again, we're going to reference our signal and we're going to use the set method. The set method can be used to set a value directly to the signal. So in this case, we can pass any value. I'm just going to pass 0 to reset it. So again, we're going to click on the plus a few times and then on the minus and then reset. It goes back to 0. At this point, you might be asking yourself, why not just keep using regular properties? For very small examples like this one, the difference might feel minimal, but with signals, we make state reactive by default. The dependencies are explicit, and we scale better as applications grow. Whenever we are talking about scalability within front-end applications, we're talking about our code base growing. If we go back to that example for the shopping cart, that example, it is simple enough, but it's complex enough as well to see where signals really start to shine. In the next video, we'll introduce computed signals. We'll see how to derive state from other signals, from our counter, for example. We're also going to see how we can avoid duplicated logic and keep components easier to maintain. If you have any feedback or if you're enjoying this course so far, let me know in the comments. Thank you for watching, and I'll see you in my next video.